Are you certain that the car you drive every day isn't a ticking time bomb? In 2026, the global automotive industry began exposing the most shocking scandals of the century. Monuments like Toyota, GM, and Honda simultaneously faced record-breaking recalls involving millions of vehicles worldwide. According to the 2025 Vehicle Dependability Study, issues reported after 3 years of ownership have reached their highest levels since 2009. Compared to the 2024 results, the industry recorded a 6% increase in the number of problems per 100 vehicles, PP100. This is 12 PP100 higher than the previous year, bringing the industry average to a staggering 202 PP100. So what is truly happening to the global auto industry when long-standing, prestigious manufacturers are constantly falling into trouble? Is the car you drive daily among the faulty vehicles currently on the market? Stay tuned for the rest of this video to discover the real reasons behind the rapid degradation of modern engines and learn quick at-home fixes to avoid spending tens of thousands of dollars on repairs. Number 7. CAFE standards. Most modern engines produced after 2020 share one common trait. They are designed to achieve beautiful numbers for fuel economy and emissions. Long-term durability is no longer the top priority as it once was. According to CAFE standards, car manufacturers are evaluated based on the average fuel consumption of their entire product portfolio sold each year. The more gas-guzzling vehicles you sell, the more you must compensate with extremely fuel-efficient models. Otherwise, the entire manufacturer will be considered as failing the standard and must pay fines amounting to hundreds of millions or even billions of dollars. To reach these ideal numbers, engineers are forced to push engines to operate more efficiently, smaller capacity but higher power output, and operating temperatures to burn cleaner. Cylinder pressure increases significantly, and the lubricating oil layer thins to reduce friction under testing conditions. On paper, this creates a car that is both economical and powerful, but in reality, it turns the engine into a cycle of continuous failure. GM was forced to recall more than 600,000 trucks due to serious engine defects. Toyota, a name that was once almost immune to breakdowns, has also faced consecutive recalls for the same issue. Honda has seen more than 1.4 million vehicles under investigation, and Hyundai has spent over $1 billion, yet the replacement engines continue to fail. Number 6. When plastic takes over the engine bay. Have you ever wondered why, beneath the flashy steel shell of a billion-dollar car, it is filled with plastic components that look like cheap toys? That is the plasticization trend currently sweeping the entire industry. To reduce weight and optimize costs, car manufacturers have replaced many metal components with composite plastics, from fuel injector covers and cooling lines to even critical oil delivery parts. On paper, this helps the car become lighter and more fuel efficient. But modern engines operate at very high temperatures. It is essentially like an oven. After about 5 to 7 years, these components begin to grow brittle, developing tiny cracks that you cannot see with the naked eye. Until one day, a coolant pipe burst, the coolant leaked out, and the temperature skyrocketed in just a few minutes. The head gasket can be blown, or the entire engine can be completely destroyed just because of one small detail. In your opinion, is saving a few kilograms of weight worth trading away the entire lifespan of the engine? Number 5. Start-stop technology. This is perhaps the most hated feature on modern cars, and your intuition is correct. Start-stop is not just annoying, it actively grinds down your engine over time. A traditional engine typically undergoes about 50,000 start cycles throughout its entire lifespan. But with start-stop, that number can skyrocket to 500,000 cycles, 10 times more. The engine shuts off and oil pressure drops to near zero. The tragedy lies in the exact moment you lift your foot off the brake. The engine fires up again, while the protective oil film hasn't had time to reestablish itself. This is called a dry start, the moment when metal components friction directly against each other. With 2026 vehicle models using oil as thin as plain water, 0W8, 0W16, your bearings are left completely exposed. Commuting in the city with 40 to 50 start-stop cycles every day is essentially 40 to 50 stabs directly into the lifespan of your bearing set. Car manufacturers call it protecting the environment, but in reality, they are forcing your engine to commit suicide thousands of times in exchange for an extremely modest fuel-saving figure. Number 4. The post-pandemic production aftermath. You may not believe it, but the pandemic itself is one of the reasons directly affecting the durability of the car you drive every day. The period from 2020 to 2023 was a time when the automotive industry quietly lowered its manufacturing standards. When supply chains fractured, car manufacturers were forced to maintain production at any cost. Factories kept running, but there was a severe shortage of experienced engineers and skilled workers. Quality control processes were shortened to save time and meet vehicle delivery schedules. Faster, but inferior. Manufacturers were forced to partner with new component suppliers to fill the supply gaps. The consequence is that many critical parts, such as crankshafts and connecting rods, no longer achieve the same precision as before. The appearance of micro cracks on crankshafts is due to reduced metallurgical processes. These defects are so small they go undetected when the car leaves the factory, yet they persist deep inside the engine. In some cases, metal shavings or even impurities like sand were trapped in the lubrication system from the very beginning. They gradually grind down vital components over tens of thousands of kilometers of operation without any warning. It is only when the vehicle reaches the 60,000 to 100,000 mile mark that failures suddenly erupt. Too late. And that is also precisely when the vehicle's warranty has just expired. 2026 is the year when the consequences of this era are beginning to appear simultaneously across the market. You do not own an ideal machine, you own the product of a chaotic period, a ticking time bomb. Number 3, machining debris. Did you know your engine is not as clean as you think, even if the car has only just rolled out of the showroom? It's not due to use. It's not due to poor maintenance on your part, but rather it may have been dirty from the moment it was fully assembled in the factory. It sounds unbelievable. But the NHTSA, National Highway Traffic Safety Administration, has officially acknowledged this. According to official recall reports, Toyota and General Motors have had to acknowledge the presence of metal fragments in the oil system. These debris pieces do not come from wear and tear, but are byproducts left over from the machining process itself. The root cause lies in the very automated production process that car manufacturers pride themselves on. A professional mechanic would spend hours cleaning each oil passage with chemicals, compressed air, and multiple manual inspections. Extremely meticulous. In the factory, however, where thousands of engines are produced every day, the cleaning process is merely high-speed automation and preliminary inspection. Not enough time. As a result, microscopic metal particles, sharp and extremely hard, remain lodged in critical components inside the engine. They do not disappear. In older engines, larger clearances in thick oil allowed these debris pieces to flow through without causing severe consequences. Temporarily safe. But in modern engines, where tolerances are measured in microns and lubricating oil is extremely thin, the situation is completely reversed. Very dangerous. A small piece of metal stuck between a bearing and the crankshaft will act like sandpaper rotating at high speeds, destroying it from the inside. After only a few hours of operation, scratches begin to form and spread across metal surfaces that require absolute precision. The first sign. After a few days, the protective layer is completely broken down, and direct friction between metal and metal causes the wear process to occur rapidly. Unstoppable. Finally, the engine can fail in a short amount of time without any clear prior warning. Number 2, the plain water oil paradox. Would you dare to pour water into your engine for lubrication? Of course not, unless you want to lose several thousand US just for repairs. But in reality, the automotive industry has been doing that even before you. 20 years ago, engines typically used 5W30 oil, a type of oil thick enough to create a stable protective film. But now, to meet fuel economy standards, oil has been gradually thinned down to 5W20, 0W20, 0W16, and on many modern engines, the number has dropped to 0W8. Very thin, almost no cushioning. It's not because it's good for the machinery, but because using thinner oil helps reduce engine resistance, saving an extra 0.5 miles per gallon, mpg, in government tests. They are willing to put your $80,000 vehicle at risk of engine failure just for an extra half mile of gas on paper. The problem lies here. For this plain water to be effective as a lubricant, the engine parts must be machined to tolerances smaller than a human hair. Just a millisecond of oil pressure drop or a slight temperature rise when you are towing in the summer, and that fragile oil film will be torn apart. When that happens, the crankshaft and bearings will grind into each other without any protection. And when that occurs, it leads immediately to direct friction, especially when you are carrying heavy loads, climbing slopes, or running in high temperatures. You are gambling your own safety on the manufacturer's promises. The proof lies in when GM recalled the 6.2-liter V8 engine for widespread failures. Their solution was not to replace components with new ones, but to instruct owners to switch from 0W20 to 0W40 oil, an oil twice as thick. They know full well that thin oil is poison, but they only admit it once their customer's scrap metal has piled as high as a mountain. You are paying for a machine designed to destroy itself for a phantom EPA figure. Number 1. Performance overclocking. The perfect performance trap. Car advertisements out there are always boasting about launching a family car with the speed of a racing car. It sounds very appealing, but if you give in to the FOMO, you have fallen into the biggest trap, because you cannot force a fish to climb a tree. And a family car cannot be forced to become a high-performance machine without paying a price, because from the beginning, it was never born for that purpose. Forcing opposing requirements into the same system, efficiency, power, and durability, is not progress. It is the source of an extremely dangerous technical conflict. One side is physics, the other side is marketing, and physics never loses. In the past, engines were designed with excess capacity, excess materials, and excess space to withstand errors and harsh conditions over many years of use. Extremely safe. Today, everything is downsized, then overclocked using turbos and extremely high pressure to generate double the power from the same volume. On paper, it looks perfect, but in reality, this means the entire system must operate near its physical limits for most of its service life. There is no longer a buffer zone. There is no longer a margin for error. A small engine forced to endure cylinder pressures over 2,000 pounds per square inch, operating continuously in traffic jams, under high temperatures, and with imperfect fuel, is no longer a durable design. It is a machine being stretched to its absolute limits. And when you stretch a system for too long, it will snap, not immediately, but at the moment you least expect it. Just a small error, one instance of insufficient lubrication, or a thermal cycle exceeding the threshold, and the entire engine can collapse in minutes. That is why more and more new cars are suffering severe failures before they have even been driven for very long. It is not because you are using it incorrectly. It is because it was designed to run on a dangerous edge from the very beginning. How can you own a vehicle that is both durable and economical amidst hundreds of pre-designed traps? The answer does not lie in choosing a perfect car. It lies in how you use it. In this era, you may buy a car based on marketing, but you absolutely must maintain it based on mechanical reality. First, a proactive maintenance mindset. The biggest mistake users make is placing absolute faith in the 10,000 or 15,000 kilometer intervals found in the owner's manual. It sounds very reasonable, but that figure is designed for the car to survive past the warranty period, not to last for 20 years. Modern engines are filled with microscopic metal shavings and utilize ultra-thin oils. Therefore, you need to apply the rule of halves. Change your oil every 5,000 to 6,000 kilometers, maximum 4,000 miles. This is the cheapest, yet most effective expense to flush out metal debris and ensure the oil film remains thick enough to protect the crankshaft bearings. Second, fuel control and periodic intake cleaning. Never use low-quality fuel in a high-compression, turbocharged engine. Pre-ignition, knocking, can snap a piston instantly. Always choose high-octane fuel from reputable stations. Regularly clean the intake valves of your direct injection engine using the walnut blasting method every 40,000 to 50,000 kilometers. This ensures proper airflow and optimal engine breathing. Third, technical intervention. The first thing you should do after buying a car is disable the start-stop system, by any means necessary. If it cannot be permanently disabled via settings, use an OBD2 module. You are eliminating hundreds of thousands of dry friction cycles. This isn't an upgrade, this is self-defense. Furthermore, once your warranty expires, consider upgrading your oil viscosity. For example, move from 0W20 to 5W30. A thicker oil layer will create a safety buffer in hot conditions and heavy traffic, something thin oil can never provide. Fourth, smart car purchasing. If you are buying a used car, be extremely cautious with vehicles manufactured between 2021 and 2024. This was the post-pandemic era, marked by many hidden defects. If a vehicle does not have a clear, documented maintenance history, walk away. Do not regret it. Furthermore, if your goal is to keep the car for the long term, prioritize naturally aspirated or proven hybrid engines. Less pressure, less risk, and significantly more durable. Fifth, proactive periodic inspections. Never sit and wait for a recall letter. You could be waiting a very long time. Check your VIN, vehicle identification number, every 3 months on official information portals. Be proactive. Do not depend on others. You need to know about a defect before it happens, not after the engine has already failed. In this era, a car is no longer an eternal machine. It is a device with a calculated life cycle. And if you do not change your mindset, you will simply become a part of that calculation. We have officially entered an era where the car in your garage is no longer an eternal mechanical asset, but a technological device with an expiration date. The car manufacturers have changed the rules of the game. They are no longer selling you durability that lasts decades. They are selling you short-term convenience in a self-destruct roadmap carefully calculated to trigger as soon as the warranty expires. If you still hold on to an old mindset, maintaining a machine crammed with 2026 technology using the superficial standards of the 1990s, you are holding a guaranteed ticket to failure. Now check your vehicle immediately. Do not wait until your wallet is drained by a blown engine to realize that you too are just a victim of the manufacturer's calculations.